Lesson 7.6, Postulates and Proofs in Algebra. We're gearing up towards geometric proofs, and we're going to do so by getting ready with proofs in algebra. Now, two statements for this. Postulate, or two terms rather. Postulate, which is a statement assumed to be true without proof, so it does not need to be proved. And square root, and that is one of two equal factors of a number. For example, the square root of 9 equals 3. Okay? Because 3 times 3 equals 9. So the square root of 9 is 3. One of two equal factors of a number. Writing proofs to solve equations. Now we've done this. We've solved equations many times, so today is no different. It's just that we are going to be asked to give reasons. For example, if I give you this equation, and I ask you to solve it, I would solve it by adding 3, dividing by 2, and we have an answer. Now, how is that different than an algebraic proof? Well, I didn't write any reasons next to it or justifications for what I did. And the justifications that we're going to use are things you've learned in elementary and middle school. And these are the postulates. They don't need to be proved. We assume them to be true, and they are on page 402 in the yellow box if you want more of this. But these are things we've done before and used before, and actually use all the time now, but we just don't know the name of the justification. The addition property of equality says that if you have A equals B, I know that I can add the same amount to both sides and it would still be equal. Subtraction, same situation. If you have two pieces equal to each other, I can subtract the same amount from both sides and it would still be equal. Again, that teeter-totter. It stays balanced if you affect both sides of the equation in the same way. Multiplication property of equality says we can multiply both sides by the same thing and it would still be equal. Division property of equality says we can divide both sides by the same thing and it would still be equal. However, there's one exception to this, and that is that C cannot equal 0 because we cannot divide by 0. It's undefined. So 5, reflexive property of equality. The reflexive property of equality just makes a simple statement that A is equal to itself. Substitution property says that if I have A equals B, that tells us that A can be substituted for B, and vice versa. I could substitute A in for B, or B in for A. So it goes back both directions, and that's substitution. The distribution property, more commonly referred to as distributive property, says that if I have A, parentheses B plus C, that's equal to, if I distribute this A, I'd get AB plus AC. Now these are all postulates, and they are justifications we can use in proofs that we're going to make. So here's an equation. We want to show the steps. Alright, so first step is, if you remember two-column proofs, we have to start somewhere, and that's going to be the given. And we say it was given to us. Always start with the given. Next, well, if we distribute the 5, that's one way to do it. And again, there's a couple different ways you can approach this, but we're going to choose this one. if we distribute the 0.5, 0.5 times 2, or 1/2 times 2 is 1. 1/2 times a -4 is a -2, equals 23. Now what did we just do? We distributed. So our justification is the distributive property. And that's enough. That would be clear enough for me. Now, notice I didn't show the distribution like we would in showing our work on the other page. Here I just said what I did. And then this represents the result. Okay? So down below, I know I'm going to add 2 to both sides. I'm not going to write it out that I'm not going to show the +2, but I'll just say show the result. And tell the people on the justification that I did the additive property of equality. Again, some abbreviations there to make it more manageable. And this is an algebraic proof. But now we have justifications. Prove that if 3x plus 8 equals 29, then x equals 7. Now this is a flow proof. It's going to look a little bit different, but a flow proof works the same as a 2-column proof. We have to start with something. Okay, so that's our given. Right now we don't have to say given with flow proof. Flow proof has steps for each arrow. So I'm going to go to our next one here, and if we look at this equation, our first step would be to subtract 8 from both sides. If we subtract 8 from both sides, we get 3x equals 21. Justification. And I'm okay if you say reasons. You don't have to write justification. Reasons would be the same. Step 1 is that we used the subtraction property of equality. All right. Our next thing would be to, we should do it in this order. We would divide both sides by 3, right? So that would be the division property of equality. And that would leave us with x equals 7, which is what they wanted us to prove. And that's a flow proof. This is all I have for this lesson. You're going to be asked sometimes to do an algebraic proof, sometimes, or excuse me, you'll be asked sometimes to do a 2-column proof, sometimes you'll be asked to do a flow proof or a paragraph proof, and that's what we're practicing. And we're starting with algebra because that's something we've done before. We're comfortable with solving these types of equations, but we never give reasons for our steps. That's our bridge into getting us ready for geometric proof. All right, and that's 7.6, and good luck on your assignment.